Good afternoon all. I've presented now on this subject twice before in this forum and also in many other places, and I knew Akim would cover the how-to, so I wanted to take a slightly different spin on it. I'm going to briefly talk about the transponder, how it's currently used, the wideband transponder that is, of course, how easy it is to receive, the EasySat theme again. The challenges that the Uplink presents is not difficult, it just presents some challenges. And then look at technical innovation that SHALE2 wideband has enabled, and I think that is the big success story. You know, finally people are doing innovative things to support amateur radio as part of self-training. As we've heard, the Uplink, the transponder is a simple bent pipe. Uplink 2401 to 2409, maybe 2410, it's a little bit wider than published. And as recently explored by some Russian pirates. So we're looking at spreading out to fill that space to reduce the amount of wiggle room they have. It's right-hand circular, exactly the same as the narrowband transponder. But one of the things Akim was talking about, thermal noise, it listens to the earth noise. So when you transmit, you've got to think, I am competing with the heat of the earth. And that's what you're transmitting against. Downlink, top end of the 10 gigs band. Horizontal polarity. So that means if you've got an LNB with 12 volts on it for narrowband, you need 18 volts to bring in the wideband. If you're old-fashioned using a bit of waveguide, that means the waveguide's got to be like that. And it retransmits the signals that we send it, but also it retransmits the earth thermal noise it hears and the receiver thermal noise. The wideband transponder, a separate TWT from the narrowband transponder, single TWT output, you know, class 80 to 150 watts, somewhere around there. We might not have the full amount of that. There is automatic level control in there to protect the TWT. And that's shared across all users, and that's quite important. We'll come to that later. Now, typically, during the day, you look at that and you'll say there's 2, 3 stations on there. Sometimes it's dead quiet, sometimes there's lots on there. And they're a mix of signals. The entry point is to use the Goonhilly spectrum viewer. How many people in the room have looked at the spectrum viewer, the Goonhilly one? Brilliant, okay. So on the left-hand side there, we've got the beacon. A couple of 1 megasymbol signals, and then an RBTV signal on the right. 2 RBTV signals on the right. And what you'll notice if you watch this is if a powerful station comes on with 1 megasymbol, he'll push the beacon down because the power gets shared. So when you're trying to peak up on the beacon, you know, if your dish at one stage says 7.2 dB MER, and it then goes down to 6.8, you haven't necessarily nudged the dish, although you usually have. It may be that somebody else has just come up and started transmitting. The reduced... we can get more of those into the transponder and use less of the transponder power. So that's the way we're encouraging people to go. One thing to note about these views, they look very nice and you can compare them to a spectrum analyzer view that you'd see in the lab. But you've got to remember, this is 1 dB per division. So actually, these signals, when you look at them on a spectrum analyzer, are less than 1 division high on the 10 dB per division view. So they are comparatively quite weak. The other thing, while we're in this view, if you think about how much power you have to transmit to the satellite, it's not just a case of height, it's a case of... So to get the same height... One, two, three. Yep. Okay. To get the same height on this display, if you're running double the bandwidth, you need double the power. And we'll come back to that later. I've just cut out here the web spectrum view of the web page. There's lots of other useful stuff on there as well. One of the links on there, am I still clicking?
Yeah. Check my press plug in.
It is. But I noticed Akim was clicking a bit as well. Try moving that. Okay. One of the links on the web spectrum view points to a list of current users. When I counted up on Thursday, there were 130 users on the list. It's a community maintained list. It's not necessarily accurate, but it gives you an idea of who is on there. And locations, include all around the edge of the coverage diagram that Akim showed. South Africa, Brazil, Israel is a fairly rare state in the middle, Russia, Mauritius. Some good coverage there. And some example pictures on the right. It is easy to receive it. I liked Akim's advice on peaking the dish using a SDR. I always, when I'm looking for the satellite, setting up a dish, I use the narrowband to find the satellite, get it in the ballpark, and then go on to the wideband beacon and peak up using Minituner to get the last dB or so. If you use an 80 centimetre dish, you'll resolve about 75% of the TV signals on there. You won't get the weaker ones because the noise in your own receiver will mask them. But 80 is a good place to start. As to what LNB to use, the PLL LNBs are good for TV. Don't expect them to be exactly on frequency. They're going to be a couple of 100 kilohertz out quite often. One of mine is, 230 kilohertz away from 9750. So when you're setting up Minituner, you need to correct for that. Otherwise, you'll find you can resolve the wider signals because you're within the passband, but you won't be able to resolve the narrower signals because you're outside the passband. The other factor is DRO LNBs. DRO LNBs do work for TV, but only down to about 500 kilosymbols. You need a PLL one to get signals below that. So don't not look because you've only got a DRO LNB. Give it a try. Receiving, you do really need a Minituner. The BATC sell most of the major parts, and it's an easy through-hole soldering job. No surface mount here. The only difficulty now is getting the through-hole parts, but they are all available from DigiKey or Mauser. And then use a Windows PC with Minitune software that you can see on the right there, or you can use a Linux PC with Longmin software. We don't package that yet, except for the Portstown transmitter, but I think in time we probably will. And both those softwares are free. Talking about dish size and received MER, about 1.8 to 2 meters is about the limit of what you get any gain for TV. We were lucky enough to be able to use a 30-meter dish at Goonhilly to try and get into SHALE2, which was a little bit of overkill. And we weren't illuminating it very well. We reckon we were only illuminating between 5 and 10 meters of it because we couldn't get to the focus. But we peaked out at about 11.7 dB on the MER. So, as Akin was saying, it's the law of diminishing returns as your disc gets bigger. But down at 80 centimeters, you're still in good shape. And in the demo downstairs in the Clubs and Societies room, we're running a 60 by 80 dish, and we're getting an MER of about 5 on the beacon. Okay, the challenge for the uplink is to be louder, sufficiently louder than the earth noise. So it's dish gain and RF power and getting a clean signal at 2.4 gigs. Typical transmit setup there. I'll just go through it because it's not that easy to read at the back. You start with a vision source. It might be a test card or a camera. And then you use a personal computer or a Raspberry Pi to drive an SDR. Lime SDR, DATV Express, Pluto. Some people have used an ETUS USRP with new radio. And then one thing that I think is essential that is overlooked is some sort of variable attenuator, so you can adjust your power. Because if you just chuck the power into a power amplifier, you'll come out at whatever power you come out at. That will either be too much and your power amplifier will be non-linear, or it'll be too little and you won't be loud enough for the satellite. So some sort of variable attenuator in there. You can generate your TV at 70 SEMS, 437 megs and transvert it up, or you can generate it directly at 2400. Either way works. But if you've got a long cable out to your dish, you're probably going to need to put your power amplifier at your dish. So you're going to want to run some sort of cable to that. And I actually use ordinary satellite cable. I've got about 20 meter run to my dish. And I just put more power in the front end of it. I put about 20 milliwatts in the front end of that bit of cable. I get a milliwatt out of the other end, which will drive my power amplifier. So a bit of cheap amplification in the shack saves the need for buying a whole load of LDF 450 or something like that. So when you come to look at how much power, we reckon that if you're doing a 250 kilosymbol signal, so that's your width, to get the right height on it, on a 1.2 meter dish, you need about 30 watts. Now, if you double your dish size, clearly that gives you 4 times the gain, so you can do it with 7.5 watts. If you're down with an 80 centimeter dish, you need nearer 70 watts. However, there are tricks you can play there as well. You can get really good recognizable pictures at 125 kilosymbols. So you can take your power down by a factor of a half, take your bandwidth down, the required power down by a factor of a half, take the bandwidth down by a factor of a half, and you've still got the same signal through the satellite, just getting less data through it. Click, click, yeah. Okay. Now, when you reduce your power, it lowers your MER. So if you went from, say, 8 dB, if you had a signal at 8 dB MER, that's modulation error rate, which is a sort of indication of relative signal strength in Minitune. If you take it down by 3 dB, you'll go down to approximately 5 dB MER. It's not quite exactly, but approximately. At 5 dB MER, you can still get pictures through if you've got enough error correction. And so you look at what mode you are using to transmit. And you'll see here any FEC below 3/4. This is not good. Any FEC below 3/4 will make it through. But if you try and get more data through by using an FEC of 9/10, now an FEC of 9/10 means that 9/10 of what you are sending is signal and only 1/10 of it is error correction. If you try and send that, there'll be too many errors, it won't get through. So again, that's another parameter you can tune. So you need a decent power amplifier. Couple of options here. To get the sort of power you want, you need either an XUMTS base station. Now, Pyro Joe has been selling the Spectrian modules for a couple of years now. Source is dried up, but every now and then he pops up with another one. Some of the driver modules I think will do about 20 watts, and the PA modules about 70. Anybody in the room got one? Something like 70. Really good. The other thing that's come on the market recently, and again now dried up, is the Axis NT Polish amplifiers. I've got one of these downstairs. They're dual channel and will easily do 60 watts a side of DATV. Very nice amplifiers. Of course, you get these amplifiers and then you've got to put them outside in the wet. So waterproofing, very essential. Recently, some people have been having a go with home-built amplifiers using the Amplion reference designs. Jim G7NTG managed to get the Gerbers out of Amplion, got 20 boards made up, and has had some very good results, upwards of 100 watts of TV out of these amplifiers. There are also some Amplion palette solutions available where these are primarily intended for microwave ovens. They're solid state microwave oven drivers. And they're great for CW, but the moment you put digital ATV in them, all the decoupling capacitors go, it's too much. They will not survive it. And 2 people have tried that, and both occasions the decoupling capacitors have blown up, even with adding extra decoupling beforehand. So the home-built Amplion design, which was in the last issue of BATC, is probably the way to go. Incidentally, it looks like we're going to have a driver PA design in the next issue of BATC, because that thing needs 10 to 15 watts to drive it, and that design will be in the next issue of CQTV. That's the Spectrian module, that side. That's the Polish PA, and that's Amplion PA. Okay, I think though the hidden success story for QO-100 has been innovation. It's probably all started with the dual band dish feed that was started off by Mike, a collaborative effort between a number of people trying it out to come up with a decent design for a dual band dish feed. Very much online collaboration that got there, and has been very successful, as we heard. The next thing that nobody's ever done before is sharing a wideband TV transponder without somebody running it. You know, people come up to me at rallies who are in the professional satellite news gathering, electronic news gathering business, and say, how do you do it? You know, we have God who runs the transponder, and you're only allowed the power, they say, on the frequency, they say. But actually, the WebSDR and the chat window has proved remarkably good at enabling the sharing of a limited resource. Now, you do need to be careful about this, because we live in an internet-connected world where I don't think there are many people in this room who would even consider transmitting on the wideband transponder without looking at the wideband spectrum monitor. But there are people who don't have that internet access, and there's no reason why they shouldn't use the transponder. And there was a case about 6 weeks ago where somebody came up on the satellite, and they were a little clumsy in avoiding other people, but they were putting in a valid TV signal. It didn't have a call sign on it, sadly, and we still don't know who they were. But when somebody else came up and it looked like they were interfering with them, they dropped carrier and so on. And there was lots of talk, oh, we've got pirates on the transponder. Actually, I think it was just somebody who hasn't got internet access and was watching the transponder on a spectrum analyzer and deconflicting using that. So we need to be careful that we don't get into the mindset that everybody on the transponder is on the wideband spectrum monitor and on the wideband chat. Okay, the other innovations then, SDR-based receivers. Sorry, this sound is not good. There are a number of SDR-based receivers out there that have come on leaps and bounds since QO-100 came on the air. Lean DVB has had some development. Now, Lean DVB has been around for at least 2, if not 3 years, and was an early effort to receive ham TV from the ISS on a Linux platform just using an SDR. That's been developed a bit and has been swept into SDR Angel as a demodulator within SDR Angel. But the real groundbreaking one is DVB-S2 GUI. This is something that SWL has developed that uses an RTL SDR or a Lime SDR as the receiver, takes it in, demodulates DVB-S2, and then on a powerful PC does the error correction. Now, the error correction had always been the problem in the past, and Lean DVB, even when it's in SDR Angel, doesn't do the error correction. So you need an almost noise-free signal to demodulate a picture from Lean DVB. With DVB-S2 GUI, it does that error correction. So a real step forward, and I think it's the first time it's been done on a PC. It's still not very easy to set up, but it does work. It does mean that somebody with minimal hardware can do it. Based receivers. Now, for that, I'm talking things using the mini tuner type satellite tuner. And for those, the error correction is done in an FPGA or an ASIC, actually within the tuner. So you don't need so much computing power for that, because you get out of the tuner a transport stream. And for a long time, we've been running Minitune, as seen there on the right. Windows-only software, free but closed source. Recently, we managed to get all the resources together, which includes the data sheets, which were under NDA, somebody with the right ability and the right time to write some software for Linux that interfaces with a satellite tuner. And that's known as the Longmin software. And that is now integrated into the BATC's ports down transmitter receiver. So it will run on a Raspberry Pi on the 3.5-inch or 7-inch screen of a Raspberry Pi, and achieves very similar sensitivity levels to the Minituner. The problem is, given that small amount of screen space, there is no way we can display all the information that Minituner displays. Most of it is available. We're just working out now what we need to put it on the little screen. We can display a little bit of information there, and as you can see, you can get rid of that to just leave the picture. That was one I photographed off screen on Thursday from the satellite. SDR transmitter developments. This bit really moved fast. I'm not sure where the intermittent is in this cable, clearly. I think it's on the top of the socket. We started with DATV Express software, which would work with the DATV Express hardware and with the Lime SDR and the Pluto. That needs a PC to drive it, a reasonable spec PC. And so we moved to the ports down software, which runs on a Raspberry Pi with a touchscreen and will drive a Lime SDR for DVB-S or DVB-S2. And that's developed quite well to be a usable system for the satellite. Still not perfect, there's lots of work to do on that. One of the bits of work that Everest F5OEO in France has done is to make some custom firmware for the Lime SDR. And this is custom firmware that goes in the onboard processor, not in the FPGA, that enables us to do higher bit rates. One of the problems with the Raspberry Pi is we have to compute what value needs to be sent to the SDR to get the right waveform. That has moved that calculation onto the Lime SDR, so the Raspberry Pi doesn't have to work as hard, so we can increase the symbol rate up to 4 megasymbols. We hope to roll that into the ports down software in the next couple of months. So there's custom firmware been developed for that. But more interestingly, for those of you with analog devices, Plutos, sat on the bench that haven't done anything, like mine hasn't come out of the box since I got it a year ago. There is custom firmware now to do DVB-S2 transmission from that on the Pluto. And we've seen a couple of examples of people running that, Paul M0EYT running that on the satellite recently. That sort of suggests that we might be able to get the ports down to drive a Pluto. The jury's out on that one. I need to look at it quite carefully. But there's a way through there, I think. The next bit of innovation is video compression. I'm going to hand this around for people to look at. Start there. We started off with the Raspberry Pi doing H.264 compression in hardware. And some people were using their PCs to do software H.265 compression. So quite a complex system. You need a big, powerful PC speaking of the network to whatever your transmitting SDR was. Then NVIDIA bought out a device called the Jetson Nano. And this is a small computer that is not unlike a Raspberry Pi. In some ways it's a lot better, in some ways it's not as good. But the great thing is it's got a hardware H.265 image processor on it. So you can use that to take an image from a Pi camera or from HDMI and encode it in H.265. Now H.265 is a better image coding codec. So for the same picture quality, you end up using about half the bandwidth for H.265. And that comes back to how much power do we need? We only need half as much power if we've got half the bandwidth. So the box I'm passing round is a Jetson Nano, an HDMI capture device, which is 20 quid off eBay. The Jetson Nano is about 100 off from the manufacturer, and a router. And the reason the router is in there is the HDMI capture device talks to the Jetson Nano over a network. And I wanted to put it all in one box. And what we've done now is you can plug in a ports down into the same network and you can control that box. So you don't need another screen. You just control it from your ports down screen and say, okay, I want to take an input from the Jetson Nano, HDMI, and I want to transmit it on this frequency and this bit rate, and press transmit from your ports down. So, and again, that is another collaborative development. You know, the software is a mix of French, people in the UK doing it, all collaborating to come up with something that produces the results. And we can now get a good standard definition TV signal on 66 kilosymbols. And Mike at the back regularly runs that on the satellite, and it looks very good. So that means he needs less than 5 watts into his dish. I think, though, the real success story has been the amount of communication and collaboration. And that's what's enabled all the things we've just talked about. We've got real-time feedback on transmission quality on the wideband chat. And that's something I don't think we've ever had in amateur radio before. You know, you've had your 5 and 9 report, which is always 5 and 9, even if the guy's got the gain turned right up and it sounds awful. No, we've got real-time feedback on video quality. We've got ideas being bounced around in the chat. And then we've got a supporting infrastructure to enable us to innovate on top of that. We're using GitHub for software downloads and version control. You know, all the software that goes into that box, all the custom software, downloaded off GitHub. All the software for Longmin, the mini tuner receiver on Linux, it's GitHub. You know, so that's the next step in collaboration. There's help and discussion. There's sort of not the real-time discussion, but the considered, I'll type this, spend about 5 minutes typing it, and then people will reply in 20 minutes, an hour, next time they look at it. Asynchronous communication. And that happens on both the AMSAT-DL forums and the BATC forum. There's the reference library of the BATC wiki. Once something is really working and that we're confident it's reproducible, anybody in this room can put it up on the BATC wiki. Editing the wiki is not difficult, and I'll give a login to anybody who gives me a good reason why they want to log in. And that good reason is you've got an amateur radio call sign or you've got an interest in TV. So don't be shy. And the last thing that's come up there is community publicity. I only found out about what was going on with the Pluto because Paul tweeted about it. Now, that's because I hadn't been monitoring some of the real-time chat and so on. But it all helps. And I think that this has all come together around QO-100, which has been really useful. So in conclusion, I'd like to thank the whole SHELT team for putting together something that's been a great success for TV. It's really forced us to do self-training in all sorts of aspects of amateur radio. One of the factors, of course, there aren't any black box solutions you can just go and buy. But anybody can get involved. It's simple to get, and you can get pictures off a 60 centimetre dish from the skip. And it's really driven innovation. So, we've got a demonstration of QO-100 receive downstairs, and the Longmin receiver, and the a typical power amplifier that you need to use. So do come and see us downstairs, and quite happy to take any questions now. Thank you.
Thanks very much, Dave. That was great. Any questions?
One very, Ian Young, G7III for those that don't know me. One very specific one on Longmin. Does it, or can it be convinced to output through X windows, or is it just directly accessing the frame buffer?
It can be convinced. If you've got a video player that will run in X windows,
Yeah.
you can send
Do it that way.
Send it to it.
Cool.
Yeah.
I was just thinking bigger screen.
Yeah. Oh, yeah. Absolutely. Yeah. You use VLC. Yeah. Okay.
I'm one of those who have a Portstown transmitter with this small, I think 3.5-inch
Yep.
touchscreen. Probably as a receive display, this is not good enough because of the frame rate, which is, well, it's good enough for a touchscreen, but that's about it. The receive video from the long bin, is it being put out on the HDMI interface, or where can one, let's say, hardware-wise,
At the moment, you can get it out on the HDMI, but that screws up the sizing of the touch buttons if you plug an HDMI in. There are a number of ways to do it. You can put a 7-inch screen on, then it looks better. You can plug an HDMI in, but the sizing isn't perfect at the moment. Or you can use the UDP output from it and pipe it to VLC on anything on your network. And that is the most reliable way.
Thanks. Any more questions? Stand aside. Oh, no.
I've got quite a few questions actually. Jules G0NZO. Are there any experiments going on using non-video modes on the wideband transponder, so wideband data?
Not that I'm aware of. The only thing that's gone on there that's not been video is some ranging experiments. Akim, have you heard of any?
There are individuals trying some ranging, and from AMSAT-UK we have been actively advertising for anybody who wants to come forward to encapsulate IP and DVB-S2, because it is in the standard. It's just a matter of doing it.
I mean, are there modes other than DVB-based modes on there? 'Cause I think there was supposed to be an
We've seen
experiment
DVB-T, but not.
I'm thinking completely unrelated modes.
No
You know,
GMSK
wide-
or anything like that. No.
No. Is that because nobody's done it, or because it's
That's
just
because nobody's done it. Quite honestly, I'd be quite happy as long as it's bandwidth efficient and social. Yeah.
not? Okay. Well, there was some discussion, I think last year, about the possibility of using some analog talkback on the extreme ends of the transponder. Any plans for that?
It's been tried. It works. One of the issues is it potentially encourages the Russian pirates. So we're being a little careful about it.
And on the back of that, you mentioned about possibility of stations who don't have access to the web chat. I was wondering, would there be any possibility of actually running a data mode on one of those extremes, reflecting the web chat, so people can actually get into the web chat through the satellite rather than having to have a network connection?
It needs a receive and transmit client for it, doesn't it? And that, good idea.
The only issue I could see with that is that you've got the possibility of non-amateurs coming in through the web chat because it's not screened, and they'd be going out on the satellite.
Yeah. There are a number of issues there, but I think the biggest one is coming up with the standard and enough people to use it, and implementing a ground station.
Last question then, or last one I
Go on.
remember. Now we've got the new firmware for the Lime and the Pluto that'll do the higher rates of DVB-S2. Does that mean that the original Portsdown modulator board, etc., is that now pretty much obsolete then?
The Portsdown filter modulator is for satellite use, not as useful as it was, but there are a number of terrestrial repeaters in the UK, of course, that still need 4 megasymbols and so on, DVB-S.
Right,
so it
it's-
works for them.
So it's still useful for the much higher rate,
Yes,
but that can't be handled through the SDR solutions at the moment.
not yet, but will be. So
Okay, thank you.
technology moves on.
Thank you.
Tony G3OVH. I may have missed something here, but is anybody actually broadcasting the equivalent of WebSDR for these broadband channels anywhere?
Sorry,
On the internet, like we can tune into the Goonhilly narrowband WebSDR.
Absolutely, yeah.
I mean, I can see the spectrum, but I mean, can you see the picture?
No, you can't see the picture. No.
That's what I meant.
No. You know, there's the live WebSDR,
Yeah.
but the issue is which picture do we show?
Manually tuned from my end.
Manually tuned from your end, yeah. How do we scale that for the number of users and so on? We have considered it, but in A, it's technically quite difficult, and B, we're encouraging people to do some radio, not some internet. And mini tuner kits are available downstairs, as the man at the back said. Yeah. Yeah.
Thanks. Any more questions?
One at the front.
Gareth, G4XAT. The data that appeared after a few weeks of the WebSDR showing us the samples per second really helped. Is there any way that it could add actually what it is? Like which variety of DVBS or S2 or MP? No, right, okay.
Not using the existing model, because actually that data is simply measuring the width of the peaks on them. So not easily.
Anybody else? Looks like we're finished then. Thank you very much indeed, Dave. Can you show your appreciation?
Thank you for listening.
And I think we're back in